This session is Computrace Backdoor Revisited, and your speakers are Vitaly and Anibal.
Okay. All right, check. Good evening, everyone. Thanks for coming in the end of the day. My name is Vitaly Kamlyuk, and I'm a principal security researcher at Kaspersky Lab. And today we're going to talk about this topic, Absolute Backdoor Revisited. It's about Computrace product of Absolute Software. This topic has been a little bit covered at Black Hat in 2009. However, we discovered more very interesting issues that you might not be aware of. By the way, how many people here are not using Mac? Can you raise your hands? Who is running PC? Very good. So I think it actually touches most of us running on a PC platform. And this topic should be interesting for everyone. You will learn why. Well, first of all, what is Computrace? Computrace is a legitimate product. It's a software designed to be anti-theft product. It kind of resides on your digital belongings, and once it's stolen, you can remotely, with the help of Absolute software, kill any file on your machine or lock your machine. And it was designed for good purposes. So the way how it works, it is a part of most of the UEFI firmwares out there of most commonly used laptops and some of the desktops and some other products too. Or alternatively, it's a part of PCI option ROM. And these pictures are actually taken from the patent. And this is described in the patent submitted by Absolute Software. So what's wrong with it? Actually, first of all, where is Computrace? If you're wondering, here's a list of vendors which is officially put by Absolute Software on their website. So you can see, maybe recognize some of the vendors of your machines. If you don't find it here, I can tell you that the list is longer. Probably not all the companies wanted to be on that list publicly available. They don't want to tell about this publicly, but our research showed that there are more vendors which are not getting on this list. Interestingly, this last vendor, Explore Technologies, is producing notebooks and tablets, and some of them are designed for military. And military people said, well, we don't need this thing, thank you. So this is not embedded into military laptops for, well, who knows why, but this is the fact. Let's move further. Why this research? First of all, we found Absolute Computrace running on several of our own machines. Some of our top security researchers found a strange process which behaved very, very much like malware. And we became very suspicious about it. Then later on, we found that some of the new computers, brand new computers, which are available at the retail store, were running Computrace too. But according to the the service agreement, you have to purchase, you have to subscribe for this service. You have to install this product and activate it yourself. It cannot be just activated on its own. But we had those machines running Computrace agent, and the owners have never subscribed to the services of Absolute Software. So we became very suspicious. As a security people, we don't trust anyone. So we tried to understand who did that, why they did that, and how it can be used. And essentially, if it can create any additional security breach to our machines. Because after all these revelations, like intelligence agencies spying on everyone, we were very, very paranoid about that. We tried to, understand how, why, and who. Well, how does Computrace work? This is what we learned during the research. It's pretty shady operation. I wouldn't probably even, adopt to market as a malware if I perceived it as a virus analyst. So how it works is from BIOS or UEFI level, the persistence module patches your system native auto-check exe each time it thinks it's the time to drop the executable to your Windows partition. So just imagine it patches your system native executable, which is already looking like malware because none of legitimate applications would go for it normally. Then the altered auto check drops and registers new system service called RPC-NetP. This is the name of the executable, actually, which is dropped on your system32 directory. But this is also suspicious, like dropping executables from another system executable. Well, that sets alarm. Then RPC-NetP gets replaced by the RPC-Net, like more advanced, fully fledged remote access, remote control tool, which is fetched from the internet from absolute control server. And if you delete RPC-Net or RPC-NetP, it will instantly get recovered with the next reboot. If it doesn't find that, it will do that. So the UEFI or BIOS modules are checking for these executables to be present on your partitions, and if they are not, they will recover it. The behavior, as I told you, is very suspicious. Once it loads, the RPC-NetP spawns svc host exe, injects own modules into its memory, completely overwriting the process, and that one spawns an Internet Explorer instance, which is also getting injected by the same module. So this is typical behavior for malware. Then they connect to the command and control center from Internet Explorer. This is very suspicious. And they do also system service self-removal. So they delete the registry key. And this is kind of confusing. You have the service running. You go to the registry. It's not there. This is kind of almost rootkit-like behavior. We first initially believed that it is hiding the key, but then it just deletes the key. Probably this is to protect from thieves. Like the thieves probably don't see that this is malicious or suspicious. Well, talking about trust, which is put by antivirus industry to these products. You can see here some statistics from VirusTotal. I highlighted like the peaks of the values. This is the detection rate. The detection rate means how many antiviruses at the moment of check were detecting this file divided by the overall number of antiviruses that was present by that time at VirusTotal. So let's say if there were 40 antiviruses and 10 detected, then you have 25% of detection rate. You can see the detection rate is changing by time. It's going down slowly. So there are still some vendors are detecting it because of obviously suspicious behavior. But the things are changing. This is whitelisted now. And our product, Kaspersky Antivirus, is whitelisting this module, and I will explain why. Well, it's actually raising a question like, should these be detected or not? And there are pros and cons. The pros, some of them you learned, process injection. It has no user notification. It doesn't show anything to the user. It's completely hidden. It does auto-check except patching, which is not normal, as I told you. Communication obscuring. The protocol is pretty heavy and hard to analyze. It has no removal tool. And you can imagine you find your machine running some third-party product. You want to uninstall it. You want to disable it. And you have no tool to do that. This is not OK, I think. For any legitimate product, you have any kind of uninstaller. If you install it, you have to, as an owner, you must have tools to deinstall it. And then it forges system service name. It looks like remote procedure call net. And there are 3 other default system services, as you may know, on Windows, having exactly the same similar name, remote procedure call something. Then it bypasses firewalls by injecting into Internet Explorer, which is also not fine. If you want to make it whitelisted, deal with firewall vendors and enable your communication. But there are some cons which prevent us from putting it to the blacklist, even from removing it from the trusted applications. This is legitimate business, which has been running for years. It is trusted by hardware manufacturers. Otherwise, they would not put it into the UEFI firmware or the BIOSes. It has digital signature. Some of the modules have them. Not the one which lives in BIOS. That one is unsigned, but the one which is downloaded from the server. It has certain integrity checks, so it does some checksums which are easily bypassable, but still, it is integrity checks. So formally, they kind of control their configuration. And this prevents us, again, one of the factors why we don't detect it. we have lack of incident reports. Nobody actually yet said that he was attacked by this tool. But maybe that is because nobody knows about this tool. And it's impossible to verify integrity of configuration. We thought that probably if we trust the executable modules, we should then control and maintain integrity of the configuration of these modules, because the configuration is a very important part. If attacker changes it, he can run this tool as a backdoor. So we cannot maintain integrity because the vendor can change the configuration, change the server anytime, and then we will have a lot of false alarms worldwide, and people will be unhappy with these erroneous detections. And we estimated that there are probably over 2 million of users that will get panicked if we blacklist this executable. Let me quickly move forward. We attempted certain attacks on the protocol because we believe that if this is a legitimate product, if this is whitelisted and trusted, then somebody put it on our machines and then somehow abused it, somehow found a vulnerability on a way to control it, to hijack the communication, and control our machines to spy on us. So we tested the protocol. What we saw is the plain text protocol coming from the RPC-NetP, the module which is a part of the BIOS, the Windows executable, which is dropped on your hard drive. We attempted two obvious attacks, replay attacks. We recorded the communication session, replayed it again, and we thought probably the agent will behave exactly the same as in the previous run, but it did not. It refused communication at some point and never continued. So it was kind of replay attack resistant. We tried live data tampering. You can see here a screenshot that during communication, this is recorded communication with a real command and control center of Absolute. We have seen this plain text past executables, and we thought, let's patch the executable on the fly so that the dropped executable will be different and we can take control over the system. So we patched the executable, and it didn't work either. The reason why is the protocol. The protocol is based on the bunch of HTTP post requests and responses, so it kind of encapsulated into the HTTP. But over HTTP, there is a binary protocol, and here is the structure of the packets, 4 different types of packets, and it sends a lot of post requests, like 1,000 of requests during session. And downloads just 150 kilobytes of data in several minutes, which is very inefficient, and this is just for obscurity from our perspective. So you see here the CK-sum, the checksum field. This is what prevented us from tampering the transfer data. When we patched the executable, the checksum had to be changed as well. And why the replay attacks didn't work? Because they have this field, the address, the blue field, which is actually the address in the memory of the agent process on the target machine. So each time you start the service, actually the addresses may change, especially when it is stacked. They can move and things may go wrong, and that's why it was rejecting when we tried to replay the communication session. This is a complicated picture, but this is how communication looks like communication session. You can see those lines marked with, starting with C, this is a client, and S means server. And this is marked with all different colors just to show you how different fields. You can see the large block here in purple transferring some larger data. But it's hard to read, so we had to translate it from the Computrace to human readable English. And this is how communication looks like. So the agent first connects to the server, and then the server welcomes with the session ID or the name of the server, and then the agent uses this to tell the server that this is me, this is the same session. And then the agent explains that it can be controlled through this address, which is a memory address in the agent address space. And the server starts issuing certain commands like allocate new memory on heap that will be used for further communication. Then the server says transfers extra strings, and by reading these strings, you can already understand what's going to happen here. Like, let me teach you some good words: kernel32, local alloc, create file, write file, close handle, winexec, test.exe. I think it's pretty clear what's going to happen here. And then the server gets the address of the kernel 32, the address of the local alloc function in there, and then he calls the function. So this is how it happens. But generally speaking, the protocol implements two basic features, read memory and write memory. So you can read memory and write to memory of the remote process on the remote machine, which is essentially basic functionality to do any kind of remote code execution. Those who has ever developed remote exploit, it's enough. Sometimes just writing to memory is enough, but this is more than enough. And it does no authentication of the remote server, so it can talk to any server who understands the protocol. So we'll show you some live demo here and some explanation about the demo environment. So we purchased this nice laptop for testing purposes. It's running Windows 8 64-bit. It has never been connected to the internet. There are no updates. That was done deliberately to prevent agent from updating on the internet. So it is the agent which is part of the BIOS of this laptop, which is getting dropped on the hard drive. However, for the sake of the demo, we had to activate the persistence mechanism in the BIOS, which drops the executable manually. It was not activated in the shop by default, but the other machines of ours had it activated. So now let me move to the demo. So the demo is actually, I have this live stream from the webcam showing the screen of the system. We are going to boot it. That's why you're going to see the boot process. It's important. But let me prepare the environment. I'm going to run my grandpa terminal. My grandfather gave it to me. He said that it's going to bring you some luck. So I'm sorry if you are not comfortable with this, but I have to do it for my grandpa. So we go to demo. We will show it a live demo over the local network. Now these machines are connected over Ethernet, and we will simulate man-in-the-middle attack. Let's say this computer is connected somewhere to the internet, and the attacker is able to hijack communications on this machine. We're not going to touch this machine or run any other processes. Everything is default. It just has activated Computrace. So what we'll run here, I'm going to run this prepare script, which actually configures the Ethernet interface. It starts at the HTTP server, and then it runs this IP tables script, which basically redirects all connections to this IP, and this is an absolute server, to my local interface. So let's run it. Okay, and then we do start, and then we'll start booting the machine. Okay, and I'll start Wireshark to let you see what's going on the network. Hopefully it will work. It's a live demo, so we can expect anything. So what is going to happen now is this machine is booting. The BIOS module finds that the agent is not there. The state of the BIOS module is activated persistence, so it will find NTFS partition. It will find autocheck.exe. It will patch this autocheck.exe, and from within autocheck, because Windows starts autocheck on boot, it will drop the system service and we'll start it. So let's wait when it boots. It will take some time. So the service is supposed to start connecting to the command and control center, and that might take some time because they actually have implemented a delay, like of 1 minute probably, to let the machine fully boot. Only after that they will try to communicate to the control server. It's kind of running slow. Okay, we got Windows booted here. Let's wait for the agent to start communications. So then the agent will try to connect to the absolute IP. They're actually IP and the domain name. We'll try both. And we will try to intercept both because we are running the own DNS servers. All DNS requests will get resolved to our IP. Or if it is connected by the IP, it will get redirected anyway. What? Your PC ran into? Okay. It's some other report. No connections yet. Let's wait for some more time. By the way, any questions so far regarding the communication and the setup? We have some time. You can ask now if something is unclear. Are you going to load an executable? Sorry? What are you going to load on? We are going to upload an executable on it using the Computrace as a transport, so to say. So something is going on here with the grandpa terminal. This is a debug output of the script which simulates the absolute command and control server. It actually talks to the agent now on that machine. We'll wait for it to complete. So what it does, it actually pushes some executables through this already established channel. You can call any API. You can run any shellcode. So just for the sake of demo, we prepared like a nice executable that can be shown. So let's look at the Wireshark. This one here, you can see a lot of post requests and responses. This is how it looks on the TCP stream. Quite short requests and responses until the part where it passes the executable files. So now it's okay, almost ready. Still running. Okay, ready to start the first module. So what we do, now we're ready to run. Everything is automated. I press enter. And it's ready to start video casting. So we will enable, now without touching that laptop, we will enable the webcam and we'll start broadcasting the video from this screen. You can see anybody sitting there. There's our elk. So it's real. You can see it's not recorded. It's live with a little delay, but still. So what we do then, we close it. We'll run another session. Next session will be just killing the machine. So next executable was not easy to implement actually. Windows 8 has protection against smart administrators. So what it does, it generates a blue screen, and now Windows creates a mem dump, and then it's ready to be rebooted when it's 100%. I just powered off, and let me start it, just to let you see that the machine is fully destroyed. Okay, it's hard to read here. What it says is your PC needs to be repaired, obviously. And the boot configuration data file is missing some required information. And this happens because the Computrace agent runs with the system level privileges. So basically, we have like full privilege. Okay, enough with the first demo. Let's move further. When we found that, we actually presented it at the closed conference in February. And then we learned that our machines are actually running RPCnet executable, which is pushed by the server as an update for RPCnet P. So we thought maybe that one also has a vulnerability, and we need to look into that. We took the executable and analyzed it separately, and this looked pretty much alike to the RPCnet P. And it has very interesting features I wanted to share with you. First of all, the executable, the P file, .exe file, creates an additional DLL file from itself. It drops on this file, copies itself and then patches it to make it a DLL, loads into own memory, then injects this DLL into SVC host, and the same executable is injected in iExplore.exe. These three processes have three different roles. They have three different tasks, and they are running the same code, the same for exe file and DLL file. Moreover, these executables are signed. So the original exe file is signed, no problem with that. And when they patch it to create a DLL, it's still signed. So if you're wondering how anyone can do that, they have it double signed. So there are two signatures. One, they produce a DLL. They just adjust certain offsets in the PE header so that since then it points to the right signature, digital signature. And there are two valid digital signatures for these modules. And we found that it uses the same command and control server in the same port. So we thought maybe it's using the same protocol, maybe the same issues. So what we saw was very similar to what we observed before, but with one difference. Maybe you can spot it. It's clear from the English translation of communication. You can see here that the agent connects to the server, says, hi, I'm there. And the server responds, my name is this. And then with the next packet, it responds again, my name is this. And this is kind of secret code for the agent that it has to speak a different protocol. And next time it talks to the server, it uses this name like 2 times. And the server understands that this is like it is an enhanced version of the Computrace agent. This is a full-fledged agent. And it can understand other things like encryption. However, what we also found that they implemented certain restriction of API calls. So only whitelisted allowed APIs can be called. But that mechanism relied on a single Boolean variable in memory. If you find a way to change the value of this Boolean variable, then you can run any API. And there was a mistake in implementation, a vulnerability, essentially. You can actually ask the agent a safe operation, like allocate new memory, and put the result, the pointer to this new memory, to this location, which is essentially causing this, write anything or add something to anywhere. And again, if this is a non-zero value, we can override this Boolean value if we know where it is. It changes the process and allows us to call any API. So we are going to show you the next demo. Our laptop is unfortunately down and needs a repair. So we'll show it on the virtual machine. I have a setup of Windows 7 32-bit, pretty recent RPCnet module. But I have to tell you that, a disclaimer, so to say, absolute customers are currently not affected by this vulnerability because we took the executable solely and analyzed it on a VM. When it is fully installed, when it is fully deployed, it comes with a bundle of other executables. Some of them are serving encryption. So the agent itself has a vulnerability, but it can speak encrypted protocol if it finds additional modules. But this is not the purpose of our presentation. We are going to explain why even vulnerability in a part of this product is really very serious. So it's demo time. Grandpa terminal gonna help us. We clean the previous setup. We go to local VM demo. I do pretty much similar stuff here. So I'm running the prepare script, which will configure the interface, will start the DNS server, and will redirect all connections to the absolute IP to our machine. First, I need to run the machine. So start the machine. So this machine has the RPCnet service. You can see how it looks like in Windows services. Remote procedure call net. There is also locator and just remote procedure call, which are default. Looks very much like legitimate service. So we run prepare, and we run start, which starts listening for incoming connections. But let me start, because I'm going to use a backconnect shell. I'm going to start the listening server in the background, and then I will start a netcat on port 4444 to listen for incoming connections on this port. So what I do next is I start this Computrace RPCnet service. Let's see what happens. First of all, on Windows side here, you can see it spawned SVC host and Internet Explorer. Okay, we got the shell. Quick and easy, and we are running with NT authority system. So you can see it's Windows shell. However, as I told you, when it comes with the encryption module, which is WCPRVXA.dll, sorry, if it exists in system 32 directory, it might not talk to our server. So let me start it again, just to show you that it will not work because of presence of this DLL. You can see that the processes are still running, the Internet Explorer, but the communication got stuck here. The last message was from the server, and the client never responded to that because the client is expecting encrypted communication. Probably that's why this method will not work when the agent is fully deployed. However, this is not so critical because the main issue is not in the fully deployed agent. We can see that this agent provides remote code execution capability, and this can be leveraged for evil purposes. That's what we wanted to tell you here. Let me clean after myself, and then Anibal will continue. Let me quickly shut down VirtualBox because I was running VirtualBox. Maybe we can continue. Can we switch on the other mic? This one on the table.
Hello. Hello, guys. I'm Aníbal Sacco, co-founder and security researcher of Cubica Labs, and I've been invited to submit together by Mr. Kamluk here. I really appreciate that. And for this part, I'm going to talk about how Computrace could be abused by an attacker after a successful scenario. These characteristics and the attacks I will describe now do not actually increase the attack surface of a system, but instead they will offer an attacker with a bunch of valuable resources to get persistency and stealthiness in a post-exploitation scenario. Oops. So summarizing, RPCNetP is the first process to establish a connection with the control server. It exposes a remote procedure call with no encryption in some cases. And no, with no encryption, this is RPCNetP. It deploys the second stage, the signed agent, RPCNet. And as it is a legitimate software, but because of its rootkit-ish behavior, it has to be whitelisted by most anti-malwares. So as it is no digital sign, the antivirus have to rely on hashes or signatures to whitelist it. And we'll see why this is a problem. So how RPCNetP knows where it has to connect to? Well, it relies on a configuration block. There is a small binary block that could be located in several places, depending on the context. In the case of a full Computrace installation, it is located in the Windows registry. And in the patent, they mentioned that it could be also located in the interpartition space, but I haven't seen it on my tests. And in the case of RPCNetP, it is embedded within the binary. So the configuration block contains very relevant information for these processes, like the control server IP address, the domain name, port number, and service tag, and even some ATDT modem commands, because it is a pretty old software. It exists, I think, like, has been there for more than 15 years. And the configuration block is not digitally signed, it is not encrypted, it is just obfuscated by a simple XOR operation, 1-byte XOR operation. And when it is located in Windows registry, it is more protected with 2 passes of XOR operation. Well, 2009, in a Turbo Talk here, I presented together with Alfredo Ortega our early findings on Computrace, and we released a tool to demonstrate redirection through registry modification. And nowadays, it's surprising, but it still works. It still works because, well, with some minor changes. And these changes are only because they added a second IP address and a second domain name, but it's quite the same.
You missed the slide. Go back.
Oh, yeah, well, okay. It's okay. So how can an attacker take advantage of this schema? Well, RPCNetP can be easily patched because as it is not digitally signed, and as I already mentioned, the antiviruses have to rely on hashes or signatures, but because of the possible different versions, they have to tolerate some minor changes. And so we have to talk about 2 different scenarios. In the first one, in the case of a machine without Computrace, a modified version of RPCNetP could be deployed to obtain a connect back mechanism that bypasses antivirus detection. The second scenario is even worse because as RPCNet is digitally signed, it can be modified to transform it in a connect back mechanism, but it relies on the configuration block in the registry that is not protected at all. So that configuration block can be modified. So it will look like this.
Who can spot something around?
So in order to modify the configuration block, one only needs to locate the configuration block in the binary or in the Windows registry, decode it, patch it, re-encode it, and fix the checksum. It only has a 1-byte checksum. I forgot to mention that. And in the case of RPCNetP, as it expects to be to be executed as a service, we introduce a small patch, just a few knobs to patch a condition, so it connects to the server every time it is executed. So, well, here you can see that it's not detected the modified version of RPCNetP is not detected by most antiviruses, at least with static analysis. But it is, most antiviruses detect the modification in runtime, but they don't block it. I suppose because of the possible different versions, but I can say it for sure. So for the demo, I will show the 2 different scenarios I mentioned before. I will show how RPCNetP can be modified to get a connect back mechanism. And for this method, you only need user privileges. And in the second scenario, we are going to modify the Windows registry to get RPCnet, the signed agent, redirected. And in this case, because you need to modify system Windows registry, it requires admin privileges.
Let me help you with the grandpa thingy. It's quite complicated. Well, go right. The VirtualBox doesn't want to unload. Conflict. No. So I think we can skip it.
I think that
I don't think the virtual. Okay, maybe
you can start
this one.
your service with
Hold on.
stopping the
No. Let's try again. Cannot unload. Okay, it's done. Should work. Our demo must work. We just run two different virtual machines because I worked on VirtualBox, Hannibal worked on VMware. Should be fine. Okay, you can proceed.
Okay. I will let Wireshark sniffing, so
You can, I think.
VMnet
You want it, right?
one.
VMnet one, right. So while Hannibal is preparing, let me just describe what's going to happen. On this new VM, we will show how these executables are detected or not detected by an antivirus, why, and what those people who rely on endpoint protection can do to at least see that this soft is modified and running, which can actually indicate an attack attempt.
Okay.
Ready?
I'm gonna configure the antivirus to use optimal security level. That's the default setting. And I want to show you that we are gonna remove all the policies that are already set. Okay. So you can see how the antivirus reacts to the tests. So,
Hold on. Okay.
okay, first I'm gonna run RPCNetP. This is the original version, and you can see that this is put in the trusted category.
So that basically happens with most of the AVs. It is trusted because it's whitelisted. The trusted zone means allow everything.
Now I'm going to make a copy. I will run the script to patch it. It should receive a domain name and IP address to redirect. Just for the test, I'm going to use 2 IP addresses, so it could be easily seen. Now, here we have the modified version. When we run it, we see that it is put in the low restricted category, and even when the modified version is detected, it's still allowed to run. So here we can see the outgoing connections to our custom server.
So here's the obvious problem. We modified the trusted binary, and this is an issue. And I think it's not just our issue. But there is a
Yes.
solution to that.
I've been testing this with several antiviruses, and even with some antiviruses, the user don't get any notification at all. Okay, so let me kill it. Okay, now for the second part, I'm gonna run the script that modifies the registry. And as it has two different servers address, I will use 4 IP addresses.
This is fully signed binary, right?
Okay, as I mentioned before, it has to be run with administrator privileges.
So now we wanted to show that signed binary, we don't touch it, but we change the configuration in registry and make it connect to the custom command and control server, which can still then control the machine. So the signed binary can be used as a backdoor.
So it was already modified. It detected, found the configuration block and has patched it. And if we run the signed agent, RPCnet, it is trusted. And
Check if it's running.
yeah. Yeah, it is running.
I think it
Yeah.
connects still to the original.
Yeah, for some reason it's not connecting to the new.
Maybe you have not patched the registry.
Yeah.
Try again. So you see that in Wireshark now it connected to the strange IP, definitely not what we use for patching. So something didn't work here. Let's try again. Kill the process and patch the registry.
I will reset the registry. This .reg just puts the default configuration block. Okay. It's weird.
So does it work?
No.
Okay, I think we can skip it.
Yeah.
All right.
What?
Sorry for this live
Yeah.
demo. Sometimes misbehave.
I told you we would need a luck. Okay. Yeah, we will skip that part.
Okay, let's go further.
But I would like to mention that changing some settings in the antiviruses, in most antiviruses, here you can see that the original version is put in the trusted category, and the modified version is put in low restricted category. And if you change some settings,
So they see that in antivirus, the interactive mode is disabled, not to bother the end user. If you disable that mode, the antivirus will interact with the user, which might be annoying to someone, but still it increases your security level. So we highly recommend to disable this, because this will definitely alert you if the trusted application was modified and tried to run some risky APIs or do some risky actions. You will get a notification. Can you show this?
Yeah.
Can you run the modified and see what happens?
If you run the modified version,
Kill the previous instances. The SVC host is from this. Maybe that's why it didn't start.
yeah. And I think I know what happened before.
Okay.
Yeah. This is what happened. We had another instance already running.
Okay, that prevented it. Never mind. Is it running?
No. It wasn't running.
Okay,
Okay.
live demo.
Yeah, I'm gonna waste more time.
So what you were supposed to see that the antivirus detects that application which is not in whitelist database, it's not signed, it attempts to inject into other process memory, and the user has to confirm that to add this application to whitelist or to stop it. So, and this is common. This is not about just the vendor or the product. It's just a common thing in antivirus industry. So if you are using endpoint protection, just make sure you have disabled that automatic decision making, so to say, so that it interacts with the user. This is crucial. I think we can move further.
Okay.
Okay. Thanks. Sorry for some failed demos. That happens. Yeah. So if you're wondering how to detect Computrace, it's quite easy to do. It doesn't hide itself. As you have seen, it has no rootkits. So you can see the RPCNet P or RPCNet processes running. If you have that on your Windows machines, you should better go and investigate why. If you don't rely on the process names, because, for instance, the attacker can actually rename the executable and you will see it as a SVC host or whatever, then you can use this YARA rule. We make it public so you can scan over your hard drive for the signatures of the Computrace executables. We recommend to do that. Also, you can detect it on the network level by connections to one of these hosts by IP or the domains associated with Absolute Software or one of its partners. And we have also developed this snort rule. Tested it already, works pretty well. You can see this, based on the communication protocol, the first server response can be easily detected so that the further communication can be stopped. This will be available on the website, I hope. Finally, our mystery. Who activated it on our machines? Who is behind it? What we did with this machine, we tried to search for the Computrace or Absolute Software traces on this machine. We couldn't find it running. The persistence was disabled, but when I searched the raw hard drive image, I found certain masks of the Computrace modules. And I was wondering, what the hell? It's not running, but still the hard drive has it. When I looked which sectors has these patterns, it turned out to be unallocated space. And I freaked out because if somebody is keeping data in unallocated space of the file system, that's too weird. But it turned out to be that somebody forgot to wipe the hard drive on the factory. And there were some files in the slack space of the hard drive. So what I did, I recovered all files that live in that slack space, and I found a bunch of documents, tools, emails, a lot of stuff. One of those tools had the pattern, which was part of the Computrace agent or the bundle of the software. And it turned out to be not the agent itself. but just software developed by Absolute. It was Absolute certification tool. You can see a screenshot here. So this is supposedly used to certify compatibility of the laptop for Computrace persistence. It has 4 stages. First, activate persistence, reboot. Second stage, check that the agent is running, the one which drops from BIOS. Kill it. Stage 3, deactivate persistence, reboot. Check that the agent is not running. Very simple. 4 stages. We ran this tool on our machine. It failed on stage 3. The stage which is for deactivating the persistence. And then we thought, well, if that happened with other machines, then we remembered that the owners of those machines, our security researchers, claimed that they bought completely new, brand new machines. The factory seal was there. It was untouched. So it was not somebody in the middle from the shop to the house of the researcher, but probably somebody before the shop who actually somehow activated the persistence mechanism. So we believe that this is some kind of a bug, either in a tool or a human error, which leads to this pre-activated state of persistent mechanisms. And that's why we see unauthorized activations and these erroneously running instances on different laptops, which essentially may create risk for you. But for us, it was good news because at least it was not somebody's evil intention. Nobody spied on us, and we kind of relaxed. But still, we learned that this product, even digitally signed, can be used as a perfect backdoor to bypass all kinds of protections, firewalls, endpoint protection, to come through all of this because of the trust put in this module. And if its configuration is altered, this is what happens. So how to deactivate Computrace? It's pretty tricky. You have to actually generate system management interrupt. You have to know certain magic values and especially the secret password that was used during activation. So it's pretty complicated and tough. And I would not recommend you do that because if you do something wrong, you may actually activate Computrace if it was not activated, in BIOS. So the best solution would be to contact Absolute Software. They expressed willingness to help every user. So if you contact them by phone and forum, they will be happy, we will be happy. Maybe they will change something in the future. Also, I wanted to stress these strange OEM strings which are changed every time the product is activated. You can get those on Linux with DMI decode tool. If you have something like that, perhaps you have this product activated. And if it runs Linux, it cannot recognize X file systems at the moment. Maybe they will develop it in the future and we'll have a Linux agent as well. But this is like a good sign indicating that it's activated stage in your BIOS. So, and finally, some takeaways, some advice. If you are an Absolute customer, make sure that the configuration is not altered. The executables are not patched. If you are not Absolute customers, I would monitor Computrace presence on your system or activation of persistence in your BIOS. If you find it, do not trust digital signatures. Just go and investigate who activated it, why, and how long it has been activated, and so on. And finally, some future research, so to say, similar case. RAdmin, maybe most of you know about it. It's like a remote administration tool, legitimate tool, has digital signatures used by system administrators. But in the wrong hands, it can be used as a backdoor. We have seen a lot of malicious bundles of RAdmin, which is running secretly, hiddenly for the user, and provides remote access to the machine, serving as a backdoor, a legitimate software. And together with this powerful technology, which is Intel AMT, I think it's advanced management technology, it becomes even more powerful. If some of you have not heard of Intel AMT, I would recommend go and read about it. This is extremely powerful. Just imagine, you can remotely, if your system is frozen, you can remotely access the system and power dev when the CPU is stalled. If it's power dev, you can still connect to the machine and bring it up. You can change the BIOS settings on the power dev machine over the network. Just imagine. And together with RAdmin, it's advertised on their website. You can do it very easily. So if somebody uses that against you, you are in trouble. You can see this Windows showing the remote BIOS setup utility. You can also start the machine from the remote CD image, which is also cool. So if somebody configures it for you, just like Computrace persistence can be configured for you by the attacker, then you're in trouble. With this, we would like to thank you, and we are ready to answer your questions. Sorry, can you say it louder?
Can you impersonate a command and control server after it's been connected to the internet? Or does it automatically download the client if it's been on the internet once?
After it has been connected, it depends on the agent. I think you can interrupt at certain stage when it has not deployed the encryption module. Yes, at some point, yes.
Does the encryption upgrade happen automatically?
Sorry.
Does the encryption upgrade happen automatically?
No, if the encryption update happens automatically. No, actually, if you, after a successful intrusion, you delete the components used to encrypt the communication, you will leave the machine with the communication done completely unencrypted. So after that, you could exploit the vulnerability he showed when you want.
Switch on.
I can speak it only. So,
Can you please explain which party you represent? Just
okay, so I'm from a German company, and as far as I understood you're saying you assume that this was unintentionally placed on those new machines. What makes you so sure? Why don't you think that this was intentionally placed on those machines for somebody to use it later on?
well, we did some forensics on those machines, on our machines, and we investigated. We found that it was first activated, was first started when the first actually booted the machine after bringing it from the retail store. So we believe it was activated well before we started using it. That's the thing. If it answers your question.
Okay, but it still means somebody placed it on the machine.
Somebody activated it on the machine. That's right.
Exactly.
So the only explanation we found was this tool. It failed when we used it. Maybe it failed on the manufacturer side. Maybe there are some machines are still, like maybe a number of machines have it pre-activated because of the bug in the tool or some human error. So this is explanation that we found for ourselves. At least our research hasn't proved that this was intentionally put for us, which was good news.
Yeah, maybe not for you, but in general it was put on there from somebody.
I think it's
It could be for somebody, and this is scary. I agree, this is scary. We did some further collection of statistics. We tried to figure out how many machines have it running. There are not like billions of machines. So our estimation is like more than 2 million of machines. We don't know how many of them have it erroneously activated. Maybe some of them are legitimate customers. You cannot just easily recognize it. But of course we collectively tried to analyze these command and control center settings. We couldn't find malicious servers yet. But still, it's worth of knowing about these issues and checking your machines. Have more questions? Can you please come closer? Just say again.
Has there ever been an official statement from Computrace?
Official what?
Like an official statement to us?
Statement. Oh, there were statements. Actually, we first discussed these issues on the closed conference at Kaspersky Security Analyst Summit, and then we published a white paper describing some of the issues. During Black Hat, we showed like more. Have you seen the remote code execution on the RPC net was extra. What they said, they actually declined the existence of vulnerabilities. They said that all the communication is encrypted from the first packet, and it's not possible. We have not showed the demo. They kind of rejected all the discoveries, but still, well, It's their choice. We have shared all our knowledge in advance with them. I mean, we provided the full description of the vulnerabilities. We submitted it to them. It's up to them to fix it or leave it like that. But it definitely creates, security risks because it can be used for evil purposes. Any other questions?
You can do a reverse DNS lookup.
The IPs that we found, sorry, do I understand you correctly that IPs that we found was Computrace? Yeah, the IP that we found was legitimate, correct. We could not find malicious IPs yet, maybe because the limited number of our sensors. Maybe there are some instances running which don't have our sensors, but who knows? That's why we want to raise this issue. Maybe you can detect it on the network level. With this node signature, you can see where is the CNC server. And if it's not one of the listed, then it's alarming. Worth of checking and stopping. Just as a last word, imagine that how the attacker can actually use it. Actually, they can change in the host file. And if the user finds the agent, removes it, it gets restored from the BIOS to connect to the run host, and then the attacker can control the machine. It's like perfect persistence with back connect mechanism. So this is really scary. Any other questions so far? I really appreciate you coming here.